Welcome. Today, we're diving into an idea that really challenges one of the most fundamental concepts in programming. What does it even mean to finish something?
Okay, so let's just jump right in with a question that honestly most people, even professional programmers, think has an obvious answer. You build the thing, you get it working, you finish it, and then you slap a version 1.0 label on it, right? Seems pretty straightforward.
Well, about that. The piece we're digging into today argues, and pretty forcefully I might add, that this entire way of thinking is just wrong. The real process is something else entirely. So first things first, let's take a hammer to this whole myth of finishing. This idea that you finish your work first and then you start versioning it as two completely separate steps. And this slide just lays it out so clearly. On the left, you've got that neat and tidy little timeline we all imagine. But the reality, shown on the right, is a lot messier. Versioning isn't a step that comes later. It's happening constantly, internally, from the very first line of code. So, finishing? That's not really an endpoint. It's just a label you put on one specific version when it's time to deliver it. Now, to really get this, we've got to zoom way, way in. This whole idea of constant versioning doesn't just apply to the big project. It goes all the way down to the tiniest, most basic building block of code, a single variable. Let's use a fantastic example from the source material. Imagine you create a variable called persona. At its heart, it's super simple. It just holds a name, a last name, and an ID. But that is just the beginning. Because, you see, for an employer, that basic persona isn't nearly enough information. They need their own version of that person, a version that also includes salary, work schedule, performance data. You get the idea. The core person is the same, but it's extended for a very specific purpose. And then let's switch gears. For a bank, that very same persona needs a completely different version. This one has account numbers, credit history, loan status, and maybe even the actual code for how to process a payment. It's the same person, but it's a totally different version of their data. And this is where it all just clicks into place. That one single concept of a person has countless different versions that all exist at the same time. There's a version for showing up on a screen, a different one for printing a driver's license, another for a credit card, and yet another for how it's stored in a database. The programmer's job is really to manage all these coexisting versions. So how on earth do programmers actually pull this off? How do you manage all that complexity in the code itself? Well, that's where the specific tools of the trade come into play. You know those big, fancy-sounding terms you hear, like inheritance and polymorphism? The source argues they're not just some stuff you learn in a textbook. They are practical, everyday tools designed for one main job, creating and managing different versions of variables. And this isn't some niche idea. I mean, look at this. C++, C#, Java. Totally different languages, but they all use the same fundamental concept, the class, to define these versionable variables. It's a pretty universal idea. And here's a perfect walkthrough. You start with a general person class. Then you create a more specific version, professor, which extends or inherits everything from person, but it also adds new specific details, like a department, and it can even change existing things, like making the title professor. That right there is versioning in action. Okay, so everything's a version, everything is flexible, we build on things as we go. It all seems to make perfect sense, right? Well, just when you think you have it all figured out, the author throws in a massive curveball, a huge exception to this rule. And this is absolutely critical to understand. This versioning mindset, this idea of starting small and extending as you go, it doesn't apply everywhere. In fact, there is one place where thinking that way can be a complete disaster. And the author uses this absolutely brilliant analogy to explain it. When you're building a database, you have to think like Superman, even if the day-to-day implementation feels more like Mickey Mouse. So why are databases so different? Well, a database is designed to outlive any single program that uses it. It has to be built for the long haul. That means you have to anticipate everything right from the start. All possible countries, all future tax laws. Because trying to go back and fundamentally change a database's structure later on, it's incredibly difficult and risky. It has to be built to last. So, if code is all about being flexible, but databases are all about being rigid, this brings us to the final and maybe the most important idea. The mindset a programmer needs to navigate all this complexity and actually finish a project. Because finishing isn't some clean, technical line you cross. It is a messy human process. It's a battle against clients who want everything done yesterday. It's a fight against our own procrastination. And it's the sheer creative struggle of taking a massive problem and breaking it down into parts that can actually be finished. I think this gives us a much deeper appreciation for the actual craft of programming. It's not just a mechanical process of typing. The source argues it's a profoundly difficult and creative endeavor, and most of that effort, just like an iceberg, happens completely out of sight. Ultimately, the source wraps up with this powerful statement. Programming ultimately is an art in capital letters, and like all art, subject to many subjectivities from both its creator and its evaluator. In other words, it's not just a science of ones and zeros, it's a creative act. And that leaves us with a final thought to ponder. After seeing how programmers have to manage endless versions, plan for eternity with databases, and just battle real-world chaos to finish anything, is what they do in art, or is it a science? Maybe the real answer is that it has to be both.